We've been doing a lot with graphing linear equations. We're going to shift gears now and look at some functions that are not linear. So the first one we're going to look at is this absolute value function. So we call it the absolute value function because, right, it's y equals the absolute value of x. So what I want to start with is we're just going to make a table. We're going to find some solutions to that equation and start graphing them to see what kind of graph it forms. It's not going to be linear like before because of those absolute values. Okay, so let's make our table. So we're going to pick some values, and I want to try both some negative and positive values. And I'm going to do more than just 3. You know, with lines we only did 3 points, but we knew it was a straight line. This one's not, so I want to do more until I can pick out the pattern here. So I'm going to go from like maybe -3. These are pretty fast and easy to plug in to +3. So if I plug -3 in, right, I get y equals the absolute value of -3. Well, the absolute value of -3 is a +3. Remember, the absolute value means the distance from 0, so -3 is 3 units away from 0. If I plug in -2, the absolute value of -2 is a +2. It's 2 units away from 0. Plug in -1, 1, absolute value of 0, 0. If I plug in 1, right, the y equals the absolute value of 1. 1 is 1 unit away from 0, so it's still just 1, 2, 2, 3, 3. Let's take those points and graph them. If we need more points, if that doesn't give us the pattern, we can do more points. We're going to start with that. So we're going to go -3, 3, -2, 2, -1, 1, 0, 0. The next point's 1, 1. So that looks pretty linear until I get to here. Right, that's not linear now. 1, 1, 2, 2, and 3, 3. So if we assume the pattern keeps going as it is, it actually looks like 2 lines that meet at that point. At that point, we call it the vertex. So let's label that. That point where the two sides meet is called the vertex. And it forms this V shape. Kind of looks just like, again, 2 linear lines put together. Okay, what we're going to do now is try to discover some ways we can graph the absolute value. If I change the equation, if I make it more complicated, so I add or subtract to the x on the inside or the outside, we want to find out what does that do to the graph. Because it turns out there's a pattern to how we can shift it left and right and up and down. We can actually make the V steeper or less steep. We can reflect it down. There's a lot of different things we can do to transform this graph. So we're going to try to discover those. That's what the point of this activity is. The activity is posted on Canvas. So what you're going to do is you're going to go to this link right here on your computer, and it will pull up a Desmos calculator. And you can come back to this or pause this if you need to look it up. But I'm going to show you the Desmos calculator here. So when you get to that link, it should look like this. So we have that graph of our function right there. Hey, by the way, this original graph, the one we just drew, we refer to as the parent graph. What we mean by that is it's like the original. It's what we always start with. So we start with the vertex at 0, 0. You know, I go over 1, up 1, over 1, up 1. It has a slope of a +1 going to the right. It's a -1 on the left side. So that's the original parent graph. What we're going to do is discover what happens as we change different things. So if you look at this first graph, I have y equals the absolute value of x plus k. So I'm going to see what happens as I add something on the outside. So if you look down here, k is equal to 0 right now. Well, what you're going to do on that worksheet is you're going to grab this slider, and you're going to change what k is. So if I go to like right there, now this would be the y equals the absolute value of x plus 2, the k is 2, so +2. Okay, look to see what it did to your graph. So our original graph had the vertex at 0, 0. You can see now that it's been shifted up 2. Let's make k a negative. So if I come this direction, there's k equals 0, right? That's my parent graph. If I make k a negative, it'd be like subtracting. So right there, we could say I'm subtracting 2. Y equals the absolute value of x minus 2. So you can see the whole graph is shifted down 2. So as I change k, this number up here, you can see how it moves the graph either down if it's negative, so minus it's negative. If it's plus, it moves it up. Okay, so it's just a vertical shift. So on that worksheet, it's going to ask you to put certain numbers in for k. Put those numbers in. and then draw a sketch of what the graph looks like. And again, we're just looking for the pattern. When you're done with that, it's going to ask you to come down to this graph. So instead of y equals the absolute value of x plus k, I'm going to turn that one off. Come down to y equals the absolute value of x minus h. So now look at that h is on the inside. So if I go to the right, this is kind of tricky. If h is a positive 2, it's actually x minus 2. See, look how it shifts it to the right too. If I go to the left, so that would actually look like this, right? It would be y equals the absolute value of x minus a negative 2. So really plus 2, it shifts it to the left. So inside, instead of moving it up and down, it's moving it left and right. Okay, it's going the opposite direction. Okay, the last one, again, you're going to do this all on your worksheet. You'll have to fill in all the stuff there and you'll turn in. Is I'm going to turn off that one. I'm going to look at A. Whoops, I didn't mean to do that. I meant to do that. Okay. So you can see what happens. You kind of saw there. We start out A is equal to 1. If there's nothing in front of the absolute value, it's a 1 because you're timesing. If I make A bigger, it makes it steeper. If I make A negative, it reflects it down. So you'll play around with that, fill in the graphs, and then write down a summary of what A does. The very last thing you're going to do is you can do a mix of all three. So if you look down here, I can change K. In fact, I'm going to hit play here. So K is changing. It's going up and down. Should be coming back down here. I can change H. That's going to start moving to left and right. So now I'm going up and down and left and right. And we can even change what A is. So now it's doing all three of those transformations. So at the end there, you're just going to make some summaries like, hey, if I change A, H, and K, what does my graph look like? So work down. So use this decimals calculator to answer those questions. Work down through that worksheet. Fill it in the best you can. If you have questions at all, let me know. But by the end, we want to just know how can I take that original parent graph that has a vertex at 0, 0, and how can I take that and move it right and left, up and down, and how can I change how steep it is? Make a summary of that, and then tomorrow we're going to go through and just do some more practice with graphic aids. Thanks, guys.